Welcome to the Global Breakthrough Energy Movement. My name is Jason Verbelli, and the name of this talk is Our Inevitable and Limitless Future, a Magnetic Field of Dreams. Now, a lot of what I'm going to show, we're just going to be sliding through this presentation because there's a lot of information, and I just want to have you get an idea of what is out there so that you can further investigate it for yourself. So I just want to give some background on things and go through some more exotic stuff later on. So here's an example of the first types of magnets that I was introduced to when my mom and my family gave me toys as a young kid. I constantly took apart my mom's refrigerator magnets and was stacking them in different ways, playing with the attraction and repulsive forces, and learning basics about their strengths and orientations at a very young age. And soon I graduated to things like this, which are located in San Diego at the lab where I currently work. And this is some magnetizing equipment and some bigger toys, some homemade magnets, and a bunch of electronic equipment that I've become acquainted with. Definitely a big step. Now, magnets are mysterious, they're valuable, and they play a major role in how we currently live, and how we will inevitably live. And in the upper left-hand corner, you see a picture more of some toys that I have accumulated over the years. In the lower left, some more experiments that I have with water and some magnetic pulsing units and things that I have done to familiarize myself with the sciences and different experiments to have fun over the years and try to get others and influence others to experiment for themselves. Now, here are some other images that I take to be sacred, whether they directly relate to magnets or electricity or not. I have misinterpreted a lot of things over the years, which has still helped me lead to understandings that I have today. And I include some of these sacred symbols like the caduceus and the scarab and yin-yang, and these images from the Pharaoh cell, like the flower of life, which are representative of magnetic fields, whether the ancients were intending them to depict them or not. Now, we all have a right to certain things as a people. We have the right to life, liberty, and pursuit of happiness and all of that. But we also have a right to clean air and clean water, and for our children and future generations to inherit a clean world. We have the means to change how we currently live now, but we as a whole need to change our financial perspective, because what we pay for and what we focus on is what we get. So what do we as a whole currently focus on and pay for? Things like war and very expensive war toys, like these $80,000 javelin rounds. Let's say half of that cost of the aircraft carrier. Let's say like $12 billion per aircraft carrier. In the lower left image, you see a boneyard for airplanes where hundreds of billions of dollars worth of material that is just sitting collecting dust, brand new, never used, and never will be used. Just a waste of money. Just some more financial perspective. Rather than spending money and allocating things on beneficial projects for health and for space exploration or for cleaning up nuclear materials here on Earth, we spend, or our military and government rather, spends things, massive amounts of money on nuts and bolts where you could get them for 80 cents in a hardware store, but this was an article from the 80s showing that they were spending $2,000 per nut and bolt. And it's probably not changed much since then. It might even have gotten worse. So the misappropriation of funds is horrendous. And it just goes to show what the collective pays for and focuses on rather than beneficial things. And the U.S. spends more than a lot of other countries combined when it comes to war rather than beneficial projects. Now look at this image. I'd rather focus on things like that. Beautiful sunsets and restoration, nuclear remediation, purifying, and cleaning up what we have done so far. And if you follow the money, it's kind of foolish to suggest that we as a whole don't have the resources to focus on solutions or a better way of life. Come on. Now we look at computers from decades ago, and we look at our handheld devices that fit in our pocket today. I love this meme. And we look at the energy and internal combustion engines that we have used for the last 100 years at least, and look at the way that we extract oil for the same types of machines that we use today. Not much has changed. There's something very wrong. And if we can't figure out a better way to harness energy in more than 100 years, maybe we aren't focusing on the right ways. Which brings us to a controversial phrase and topic, free energy. Now, to me, the term free energy applies to just that. Just the energy that you harness is free after you set up a system and pay for it to get to an initial setup and a final result. It does not mean free manufacturing or free parts or free installation. It means free energy. Simply means that you don't have to pay fiat currency for harnessing electricity after something is set up. Doesn't mean energy magically from nothing. Like a hydroelectric dam and Hoover Dam has been going for over 80 years nonstop because it's harnessing an already existing cycle as an open system. And there's nothing violating any laws. It takes money to set something up, but it's providing a lot more energy than it takes to maintain and keep it going. And I have a little saying, people who say that there is no such thing as a free lunch have probably never picked wild berries and just called it lunch. Now, free energy is about harvesting what's already present, what's already around us, but in a way that doesn't result in you having to pay to maintain the system. So people who suggest that nothing is free, well, correct, the parts aren't free, but again, the energy that you harvest is free, like from Casimir crystal batteries or from wind turbines and hydroelectric dams. There's always a way to harness something in a non-linear way, instead of having to do something on a ratio of 1-to-1 or even less than 1, which brings us to the next slide. And I equate so-called free energy to a linear income and how we work really hard for the money that we earn. And working hard is not necessarily the best way when we could be working smart in a non-linear fashion. Everybody knows that you spend a certain amount of time during the week, you get paid a certain amount. If you work a little bit more, then you're going to get paid a little bit more. If you don't work at all, you don't get paid at all. That's the linear way of life. 40 hours a week. It's what the world does, and that's not the only way. Now, a lot of successful people create a mobile application, or they create a song, or an invention that everybody uses, and they perpetually get income because they have something set up when they worked smart and they worked hard for a bit of time, and then it reaps a nonlinear result. So as an open system, money can come in from all sorts of places while you can sit back and enjoy life. Likewise, if we spend our time and energy and money in projects that can harness energy as an open system in a different way, then we can sit back and still harness the electricity without having to work so hard and pay for it, while we can focus on things that we do love. So the concept of harnessing so-called free energy is similar to the concept of residual income. Once you get a system built and established, outside resources can funnel in and maintain it. The way we use energy now is like working a 40-hour week. It's working hard but not necessarily smart. And it brings us to a story that I found called The Parable of the Pipeline, written by Burke Hedges. And this is a story about two guys, Pablo and Bruno. And Bruno is all about the hard work, and Pablo is about the smart work. Is it about buckets or pipelines? We go to the next slide, and we see Pablo and Bruno, and they live in this town. And there's this road that goes to this lake, and if they want the water, they have to carry buckets down the road to the lake. They get the water, and they bring it back to the town. If they want money, they have to bring more water. The only way to do that is to go more frequently or to have bigger buckets. Now, the amount of water that they can bring and the amount of time it takes, they know. And if there was a better way, which there was, Pablo was spending his time on figuring out that way. And he was working smart, trying to build a master plan of a pipeline to bring that water from the lake to the town so he didn't have to carry buckets in a linear fashion. He could sit back while the rain filled the reservoir and then the water ran into the town. So if we're willing to spend time, money, and effort to pursue a long-term beneficial future, we have to work on things that are a bit different than how we do them now. And after Pablo finished his pipeline, he actually put Bruno out of a job, and he created a source of income and water for everybody that was self-sustaining, which is what we are trying to do in San Diego now. One of my favorite quotes is from Margaret Mead. "Never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, it's the only thing that ever has." And what you see here is our efforts built up since 2010. We have a magnetic facility so we can study different phenomenon. And we have a machine shop so we can fabricate our own magnets on our own materials and study them on a very small scale, apply them and test these different theories and see what works out and try a different way of generating energy, which we'll go into later. We have a good grasp on what magnets can do, but humanity is still in its infancy stage when it comes to magnetization processes. Magnetic gradients, or coated magnets, rotating superconductors, electrets, and other exotic materials. What you see on the left side of this slide is a homemade magnetization set up by Fernando Morris to investigate the theory of magnetic waveforms. You see Tom Vallone, which is a good talk on American anti-gravity, and he's talking about magnetic motors and magnetic gradients, which is one of the few untapped branches of science, which again that we are exploring in San Diego. Below Tom Vallone, you see an image of Dr. Eugene Podklednov, who works with rotating superconductors and is an unacknowledged researcher, was suppressed by NASA and the Department of Defense. And to the right of that, you just see some basic images of coated magnets from correlated magnetics research, or polymagnets, which we'll get into also in a little bit. And we use magnets in everyday life and take for granted a lot of their daily applications, from hanging notes on refrigerators to generating our everyday electricity, to picking up objects in junkyards and maglev trains, speakers, and medical applications like MRIs. But here I wanted to go over some conventional and normal magnets and then move to some more exotic concepts and claims. Now, magnetization itself is a process of electrifying a metal through high capacitive discharge into coils. The process is relatively primitive and is a standard used internationally. Usually requires a lot of power for larger samples. There are many steps before the final stage of magnetization of an actual metal when it comes to standard industrial processes. ferrous metals can become a magnet when in the presence of an already existing magnet, like ball bearings or paper clips and little pieces of metal like that. Now, there's all different kinds of magnetism, which I've listed at the bottom of this slide. What we're focusing on is more of the coated magnets and a new concept of magnetic waveforms. But just to give you some context, here are some standard types of magnetization orientations. Axially magnetized, which would be the top half of your body, the bottom half. Diametrically magnetized, which would be the right side of your body and left side of your body. And radially magnetized, which is like the inner diameter and outer diameter of a ring. Now they have U-shaped horseshoe magnets. There are radial arc sections, and there's all different types of magnets. A good video to reference on YouTube is this by Super Magnet Man and how supermagnets are made. He got the opportunity to travel to China and see the process from an industrial point of view, all the way from the ingot, which are these large moon rock type materials of the raw material itself, all the way through the magnetization. And just to give you an idea of how technical it is to make some of these very strong magnets that are made for generators and not the type that are just found on refrigerators. We're talking very strong neodymium-based magnets. And here are some of the steps in making those magnets. There's over 10 steps in all, and I put together this list from Super Magnet Man's video. Most magnets are axially magnetized, top half, bottom half. Now what you see in this slide in the upper left is a green sheet. It's called a magnetic viewing film. It has very tiny magnetic reactive particles in a fluid, and they're smashed between two laminated pieces of plastic. And that fluid is like a couple microns thick. It's like the diameter of your human hair. Now, when you hold this green film up to a magnet, the angles of the particles change and allow you to see the reflections of the so-called line separating the north from the south. And this visible line through that green sheet is called the block wall or the blotch wall. Now, a lot of people have different terms for it. The dielectric plane, the inertial plane, the cathode plane, the zero plane. I personally like the least amount of syllables, the better. Block wall. And you can liken it to a CD or a DVD or a flat disk. And I also liken it to the common wall shared between two bubbles. It's one of the few things in our 3D reality that is flat. It still has some thickness to it, but everything within that soap bubble film connecting two bubbles and that little wall has no z-axis to it. And the block wall itself is sort of the point where the magnetism diminishes to zero from each side, from the north to south and south to north, going to zero towards the equator. Now, a good video to get an idea of the shape of a magnetic field in general is this listed here by Uniserve Science Video. And what he did is he has a 3D array of compasses around a horseshoe magnet. And you can see the layers like an onion around that magnet and turning it in 3D, and you can just see the overall shape. Now, when you put ferrite or you have compasses around a magnet, they're going to help you identify the magnetic field lines. And when you have this green sheet, it'll help you identify the block wall, which is not the same thing. And what you can see with these green sheets, as in this next slide, when you have a bunch of magnets stacked together, you can see the lines separating them in different ways, and they each create a geometric grid in an array. And depending on what shape magnets you have and how they're going together, you can get all sorts of geometric patterns. And that's when they're stacked in ways that they want to be, meaning if you just let them go and they naturally stick together. You can see patterns of these block walls. But what happens if you force together magnets even though they want to repel, and then you keep them there? Which is difficult to do, but what you can do with that is you can make patterns and you can form other grids out of these block walls. And instead of them being more straight lines in grids, you can have them be rounded. You can create little spy things with them. What I did is I drilled holes in pieces of plastic, forced them together in an arrow. You could have that behind a wall, and you could put up the green film to the wall, and it would show up the arrow, you know, whereas nobody else would see unless you had that green film. Be fun toys for kids, and just to have them learn basic principles of magnets and create their own patterns. But what I was doing with this is I was trying to make some wavy patterns, some waves. Now the block wall, again, is different than the magnetic field lines. When you pour iron shavings around a magnet, they'll expose the shape of the magnetic field lines. But what I was doing is trying to force these magnets together in ways that they were angled so that the field lines would sort of make a wave. And I wanted to keep them there, and I wanted to spin them and see how they behaved and just do some experiments. And I have a lot of YouTube videos showing these. Some of them are lame, some of them are more interesting than others, but the point is to get people to watch, to think for themselves, and to influence others to figure out these mysterious things called magnets that really nobody knows how they work or why. We have theories, we have the best ideas, nobody really understands. It's interesting to see if you can be somebody else who will contribute information to that, because there's a lot to discover still. And in my journey of trying to force these magnets together and figure out what happens, of course, you come upon a Hallbach array. And what that is when you force together magnets in such a way and keep them there that the magnetic field becomes uneven on one side than the other. So everybody knows a magnet has a north and a south, and the magnetic fields are relatively, they're even on both sides. Even though there might be more mass on one side of the magnet than the other, because there's not the same amount of atoms making something up, the magnetic field is pretty much the same on both sides of a magnet. But if you force magnets together in this way, a Hallbach array, it compresses the field on one side and it will reinforce it mainly on the other side. It's not canceling a magnetic field, but you can get it to warp in different ways, and the patterns will show accordingly. And here's some more diagrams about a Hallbach array. You can see normally is called an alternating polarity, when you have magnets stacked together the way they want to be. North, south, up, down, up, down. And you can see the shape of the field. If they're all forced together in the same way, you can see that shape of the field, which coincidentally looks like an electric conductor. And then a Hallbach array when you force them together. But these are all cartoons. It's not real. It doesn't exist. There you go. I need a slide to show them real. And this is a guy on Ian.org. I assume it's Ian who put these together. Has a Hallbach array wrapped in aluminum foil, and then he put some iron shavings, ferrite shavings around it to see the shapes of the field. And indeed, it is exactly representative of the diagram in the last slide, that it has these points of compression and expansion, I say, rather than cancellation. I had the opportunity to visit Stanford University a few times for tech conferences in the San Francisco Bay Area. And while I was there on one of these science fairs, they had this business card-sized magnet. And it was from Center for Probing on the Nanoscale. And it was like a refrigerator-style magnet. It was kind of bendy, but it wasn't a normal magnet. It had these multi-poles on it, these little microscopic, nanoscopic ridges. And when you have two of them together, it's like they could fit together your fingers this way. But if you tried to rub them the other way, it would be really hard. You can feel the brr, 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 brr. You couldn't see anything until you had this magnetic viewing film, at which point you see all these tiny little little hair thin lines. And I had never seen a magnet like that before, and I still haven't seen any since. It was like they only did a one summer course on these magnets for the science fair, and then they didn't do anything further with them. I haven't been able to find them since. But there are multi-pole magnets, and there are all different sorts of magnetic orientations. Now, when you wrap coils, you can make electromagnets, and you can also duplicate these type of fields. And brings us to the next idea, which is an example of Marco Rodin's coils, which is a geometric winding pattern. And what I have on the left side here is a circular protractor, 360 degrees, and I wound the wire as Marco showed me, which is once every 150 degrees, 12 points, and I have an example on the right of this coil. And you take this Fisher-Price baby donut, and you wrap the wire over and under and through in a geometric fashion. And I put together a video, almost all in one take. It's about a half an hour, and it's a Rodin coil tutorial. So I show people how to make them on the spot, and you can experiment because there are some anomalies and some cool experiments that you can try for yourself and get some understanding of the magnetic fields and electricity in general. You can make these into speakers. You can study this monopole so-called anomaly that I still haven't really figured out. There are spin tests to make magnets spin, like hundreds of thousands of RPM. You can make ball magnets levitate, and all sorts of stuff. So here is an example from Jamie Buterf. And this video was uploaded by another individual, but the coil itself was wrapped by Jamie Buterf, and it shows this ball magnet being levitated in the center of the coil. And everybody loves levitation. Next here we have the difference between a starship coil and a Rodin coil. Now, a Rodin coil is wrapped around a toroid or a donut, but this man named Richard Motzer, who doesn't get enough credit, he is known also as HHO for volts on YouTube. He wrapped the same geometric pattern, but around pegs and dowels rather than over and under through a donut. And he found that you're not limited to the size, because you are only limited to the size of the donut when you're wrapping the Rodin coil. And he found that the magnetic field is a little more concentrated at the center of this starship coil. And I highly recommend people going to his videos and seeing his perspectives on the original wrapped starship coils. Now, whether you're wrapping a starship coil or the Rodin coil or any geometrically wound coil, there are some strange claims. Now, there is this man named John Fiala who works at the Tesla Technology Conference, and he worked on a military base and had a horrific accident where some explosive tore open his gut. And he was told it would take over 8 months of healing with multiple skin graft surgeries in order for him to maybe fully recover. But with the aid of one of these geometrically wound coils used as a magnetic massager through pulsed magnetic fields, he says that he was healed in 32 days completely without any skin graft surgeries. And he speaks about it often, and that's quite a claim. So whether it produced some benefit or not, 32 days healed rather than 8 months without surgeries, that's pretty phenomenal. So that should be further investigated. And this there's a video on it again by Jamie Buterf called Healing with the A432 Hertz Music Coil. And Jamie Buterf, he does a lot of beautiful work with these coils. Here is Richard Motzer's Starship coil design, but wrapped by Jamie Buterf and used as a speaker. Now, I have this black box that I acquired from one of my friends, and this black box is similar to to the claims of these geometric wound coils, and also similar to the work of Dr. Robert Beck. It's claimed to promote healing and benefit somehow, and it's like a magnetic pulsar unit where you can adjust the frequencies and harmonic frequencies. And I've used it on glasses of water, on colloidal silver, and I haven't really made any comparison other than growing plants using that water. And indeed, the plants did have some benefit, but I didn't isolate all the factors, so I can't say that it was specifically because of that. Going back to this Rodin coil by Jamie Buterf and this alleged monopole anomaly. Now, this is one of the more interesting things that I encourage people to wrap their own coils and check this out. Go on to YouTube and check out magnetic monopole anomaly. And what he did is he has this Rodin coil, and he has a load on it, and he takes this Allen wrench and he puts it in the center of the coil. Normally, if you have a coil around a piece of metal and you connect that wire to a battery, you'll make that piece of metal in the center of the coil a magnet. And then you take it off the battery, it's no longer a magnet. That's what an electromagnet is. And when you do that, you get a north and a south, top half, bottom half. But when you put a piece of metal through the center of this Rodin coil and you apply current to the coil, no two poles can be detected, only one of them. And you can test this with compasses, and you can test this with a pole finder, an electric one. It's just a very interesting anomaly that I still haven't found out how it actually works just yet. So something weird, got to share it. I'll also encourage people to visit Pythagoras432.com, which is Jamie Buterf's website, and you can learn more about these magnetic pulsing units and these Rodin coils professionally made, so you can investigate them yourself. And lastly, with this monopole anomaly, there is this gentleman on YouTube, Dan Prada, who uploaded this video. I'm not sure about the title, but the video itself is interesting, showing the difference between this geometrically wound coil and a normal coil, and indeed the compasses are pointing and there's only one pole to be found. Now, there are a lot of different magnetic researchers that I have found, and there's just too many to list in one talk, but a couple of under-acknowledged magnetic researchers are Pier Luigi Aguina, who worked with Marconi, and he developed this theory called the magnetic atom. He was known as the Tesla or Wilhelm Reich of Italy. His focus was cosmic energy inventions, magnetism, patterns of nature, coils, the importance of geometry, harmonics, and color for therapeutic uses. He developed his theory called the magnetic atom, and he also developed a lot of therapeutic devices based on coils and painting them and rotating them. And it's debated that he had a better method of cloud busting than Wilhelm Reich. And this is well documented in Italy, that he was able to part the clouds or make it rain within 10 minutes to half an hour. And this is filmed, and you can go online and see some of his very strange work. Also, another under-acknowledged magnetic researcher is John Depew, who has a theory of the magnetic spectrum, and you could go on to coralcastlecode.com. He says that everything in the universe is pretty much made of three things: north magnets, south magnets, and neutral particles of matter. And that got me thinking a lot. So then I look back at Pier Luigi Aguina's perspective, and I look in the top right of that slide, and you see this triangle. So what you see here is the 1/1 is a regular ball magnet. And then he has a piece of iron straight, one connected on one side, one connected on the other. And then just regular ball bearings connected to those pieces of iron. And what he gets is those neutral particles become a magnet themselves. And Pier Luigi Aguina says that that is the equivalent of a monopole. That A ball bearing or a piece of metal is like a building block of matter, and when in the presence of another magnetic field can connect and become its own pole, but only if it's a part of a larger circuit or system, but not that there are monopoles unto themselves. If you cut a magnet in two, you're going to get two magnets. That's indefinite. So if you have other pieces of metal as building blocks on certain sides of the magnet, then you can have a simulation of a monopole, and there's always a catch. And that's what this man on the next slide, he demonstrated, and this is Tin Man Power. A lot of people love his videos. He has a piece of metal on top of a magnet, and then a bunch of ball bearings on top of that piece of metal. And what happened is all of those pieces of metal adopted the field of the side of the magnet that they are connected to. So he placed a piece of metal on the north side, negative, and then a bunch of ball bearings to that, and he put a compass, and indeed they were all negative. Then he took a south side of a magnet, and he was able to push them like a little magnetic motor, and indeed it works. So there are, Hallbach array motors and different style motors, not quite free energy, but it's still very unique and interesting setups. A couple more under-acknowledged magnetic researchers, Albert Roy Davis and Walter Rawls Jr. Two of my favorite books are The Magnetic Blueprint of Life and Magnetism and Its Effects on the Living System. These guys had a lot of documented work with therapeutic uses of magnets and the shape of the magnetic field, which went beyond the ferrocell or the ferrite particles or even the magnetic viewing film. They were saying that there are two donut-like shapes on top of each magnet with vortexes, and they were able to show that for the first time decades ago. They have a website called magnetage.com, and I suggest people read the frequently asked questions page on there because it gets kind of confusing to people when you're dealing with compasses and magnets. But they developed a therapy called biomagnetic therapy, and they claimed to have the science and documentation to show the benefits of these specific magnets placed on different parts of the body for different periods of time, and it would alleviate certain ailments. So I was looking at their claims, and I was looking at the pictures of blood before and after magnetism therapies. And boy, they looked a lot like these so-called structured water therapies, when you have water cycled through some geometric device and then people drink the water, and it's claimed to benefit the system somehow. And indeed, when you look through a microscope at the blood, you can see similarities between these stacked red blood cells and rouleaus and symplasts. And then when they drink this type of water or receive this biomagnetic therapy, the cells change. They become more individualized, more buoyant, more magnetically repulsive to each other. And that means more surface area to absorb more oxygen, more to deliver more nutrients, and have more charge. So there are similarities between this biomagnetism treatments and these structured water treatments. And the reason why I was interested in the so-called structured water is because of the magnetic components introduced in some of these setups. And here is a picture of some of those examples. On the top, you see an example of Dan Winter's imploder nozzle, which is a 3D printed spiral nozzle which forces the water to spin on itself and back again. And after it does so, it is sent through an array of these magnets that are forced together even though they want to repel. And what it does is it somehow benefits the water. And there are other machines or units that they even sell in Home Depot and hardware stores that you could put around your gas line, or you can put around your water heater in your house, and it's claimed to soften the water or benefit the water somehow. So this isn't a new idea, and it's not a so crazy idea. They're being applied now in different industries, but the claims for each are different. So some say it softens the water, some say it structures the water, some say it changes the molecular makeup. Whatever it's doing, it's benefiting the water somehow. And when you water plants with it, you can see that indeed the plants grow faster. Plants don't have placebo. They're not going to fool themselves. So that I take as conclusive proof that there's something happening with the water. So whether you send it through magnetic fields or you send it through hexagonal arrays, it's doing something. And it's simulating the same benefit as these biomagnetic therapies. Victor Schauberger would be proud. Now, I put together another video on YouTube called Super Imploder Magnets and Water Structurizers. And I took apart Dan Winter's unit and a couple other people's units, Clayton Nolte, and I tried to get an idea of how their theories for their water units were working. And that gave me the information to put together my own units and combine their info. And I made videos to try to help other people understand that. Now you can find out more about Dan Winter's imploder nozzle with these phase conjugated magnets, which are just forced together even though they want to repel. Go to fractalfield.com/imploder magnetic research. And just to show you that this isn't just all talk, here's some side-by-side comparisons of plants and yields, food, real tangible stuff benefited by this water. And this particular piece on the top two images of this slide comes from rainmakerh2o.com, and the last two on the bottom are from Dan Winter's setup. So whether you use magnets, whether you just cycle the water through like a resonant cavity, make it cavitate, whether you promote the hydrogen ions, whatever you're doing to the water, it is benefiting it, and you're getting almost twice as much food. So that you can't deny results. Which brings us to the work of Gerald Pollack and Stephen Settlemyer and their experiments with exclusion zone water, or so-called EZ water, which is now called deuterium-depleted water. And the reason why I'm mentioning this is because of the magnetic component required to make this state of water. And there is an excellent video on YouTube called Electrically Structured Water, which promotes the work of Gerald Pollack. And what you see here is the work of Stephen Settlemyer, who is an associate of Gerald Pollack. And this is a very unique distillation process that uses microwaves at 5,000 volts inside of a resonant cavity. They distill the water about 14 times, and as it's cycling through this unit. And there's a magnetic field. At the same time, there is a electric field. And what it does, he says that the distillation process makes for the molecules to be, as an analogy, more elastic, so that they're easier to split electrically. And when you do, under the presence of a magnetic field, it renders the water into another electrical state. And I have this video so that you can see exactly what is going on with that. So just take a moment to see this. Now what you're seeing here is the rings that represent oxygen, and H2O is like the Mickey Mouse ears, and you see that coming together. So that's the H2 and the O. Now, Stephen Settlemyer says that the electrical bonds making up the ears of that H2O are spinning in opposite directions. They're counter-rotating. But his process, after you do this electrical process under the presence of a magnetic field, it makes for those bonds to spin in the same direction and stay that way after the process. And that is has been debated for years. A lot of skeptics, rightfully so, have questioned so-called structured water, saying that it can't remain in that state. You can't alter the molecules unless it stays that way for longer than a nanosecond or microseconds. And that's true. You cannot change the bonds indefinitely, except if you have this new process. All of the other units that are cycling water and so-called structuring the water are doing some benefit. Whether they are rearranging the molecules, rearranging the electrical spin of the bonds or whatever for however long of a time, it seems to make plants grow and benefit. I use it for myself and my dogs. They like it. I like it. It works. So the makeup of the bonds and the molecular stuff can be debated, but not this particular process. This is a documented process, and the benefits are also documented. You can visit diviniawater.com and find out more about these claims of this water. Now, when you render water in this state, it does different stuff. And you can see that as an example through concrete and industry. Stephen Settlemeyer says that these tests have been done, and I was able to communicate with him a few weeks ago, and he sent me all these documents, of which I'll have available for other people to scrutinize. He says that during these concrete tests, normally it takes concrete to set in 28 days. And I did some of my work in my own house, and I can attest to that. It takes about a month for concrete to fully set. But he says when you mix it with this type of water, the concrete will set in 4 days while being twice as hard, so that you can use half the concrete in a job and it will be done in 4 days. Now that is a claim for industry to investigate. Another claim is that it will emulsify oil and water. Everybody knows that oil and water don't mix. You pour some oil on top and it will just sit. When you shake it up, you'll get little bubbles of oil, and then it'll eventually go to the top again. If you want the oil to mix with water, you have to mix some dish soap or a surfactant of some type to mix the oil so that it's able to mix with the water. It's called emulsifying. But with this type of electrically structured water, the oil and the water, when you shake up a bottle, it will just 100% mix and stay that way. That is strange. Water does not do that without a surfactant. There are claims that you can use this water as a fuel additive to make biodiesel and other fuels last longer. I'll show you that in a sec. But the other claim that I haven't seen is that this type of water eats through plastic. Now you have to keep it in glass bottles. So maybe that can be used for helping clean up waste plastic, which takes a long time to decompose. Again, Stephen Settlemeyer sent me a link through email, which is about 20 PDFs and case studies showing the benefits of this magnetically and electrically treated water. And a man who needed a liver transplant was drinking this water and completely was healed and didn't need a liver transplant anymore. That's a very big claim. And another claim with kidney failure, and this gentleman who was drinking the water and he didn't need like dialysis anymore and didn't need a kidney transplant anymore. That doesn't happen. So it's another claim to investigate, please. Moving on more to the magnets, the more exotic stuff. So we got polymagnets, Correlated Magnetics Research. Now, this is an image of some of their coated magnets. And what they have is a process, which is still a semi-standard process electrically, but it's an exotic new way of making magnets. And they put these magnetic dots onto one material, and these dots are called maxils, like magnetic pixels. And I was one of the first people back in 2010 or 11 to get these magnets when they offered them in their original kits. And I made this video called Geometrically Coated Magnets Behave Differently. And they have these codes on one side, they have an inverse code on the other side, and even though the magnet wants to attract, it will repel at the last second. So these little dots of magnetism want to repel, but the overall magnet wants to attract, so that meets an equilibrium where there's a little gap. You could use those for like cabinet doors that don't slam shut, or toilet seats that don't slam shut. You could use it for bed, the feet of bed, so it's hovering over the ground, so you don't have them squeak. They have over 80 or now over 100 patents having to do with these lock magnets. You can use them as locks, and there's just all different types of patterns that you can encode onto these materials, which will result in different behaviors. And I put together another video on YouTube where you can see these magnetic field tests, and I'm comparing the regular axial magnets with these coated magnets and radial, and just getting a feel for them and having other people see the differences, you know, on a magnetic viewing film, and how they react with the iron particles, because I love magnets. Want people to understand their awesome nature. And I was looking into how are they making these coated magnets. So I wanted to try to make them myself. And what I did here is I put together 19 nails, wrapped coils in a hexagonal grid. And I drilled holes in a piece of plastic and tried to make them as even as possible. Connected all the red ones together, connected all the blue ones together, and wanted to see if I can magnetize a piece of metal with it and have these little squiggly lines, little magnetic waves. See if I could code a pattern onto a magnetic material. And I attempted it about 8 times, different ways, going through the information that was available. Not quite been able to do it because I didn't have the amount of power, and turns out I was using the wrong side of the nails. Should have used the sharp side. But I did influence other people to start studying this concept. And what you can see is I forced together these magnets that want to repel, and I have them in this grid, and then I put the nails together, and then I hit it with electricity from just a regular car battery, but it didn't seem to do exactly what I wanted. And this is what the type of stuff that they're doing. This video is by Correlated Magnetics Research, CMR, now known as Polymagnets, and they have what's called a mag printer, and it's a different form of magnetization. Still use the same conventional power, but instead of making a magnet just north and south, what they're doing is they're using a 2mm print head, and they're blasting a specific spot localized on the magnet to make a little dot. And I re-uploaded their videos so people can get context on the difference between these things. And here is a list of almost 100 of their patents, which I still have, and it's just reading through them. They have a lot of interesting stuff with locks and space docking. Really interesting stuff. Let's see here. Go to the next one. This is Devin from, let's see, the Mind-Blowing Magnets, and he went to the Polymagnets and filmed this in Huntsville, Alabama. This is from Smarter Every Day on YouTube. And just a moment here. And what he did is he went there and filmed these examples of their coated magnets in person. The president has also visited their facility since then, and they have become a lot more well-known now. But still, people don't know about coated magnets. And when I uploaded my video in 2012, I was fighting with people online. They didn't believe in coated magnets, and they're fighting with me, saying it's a hoax. And now what? Now can't deny the results. So this is a really interesting company now, and they're becoming more well-known. Brings us to Tom Vallone and Integrity Research Institute. Now, Tom Vallone is talking about magnetic motors and magnetic gradients. Now, before, people are trying to use a bunch of different magnets, forcing them together in different ways, trying to make a magnetic motor spin and keep it spinning, which is very difficult, apparently, and I haven't seen anybody do that. Maybe Muammar Yildiz is a contender, but for the most part, you can't just make something spin with magnets forced together. But people have tried, and one area of science that is untapped is magnetic gradients, where you have different strengths of magnets on a material and going in a wave. And that's what these V-gate magnet motors are trying to do. And there are people trying to make these things and now trying to outsource these companies, trying to make these magnetic dots on materials in specific ways and trying to do the old ideas of magnetic motors where you were trying to force together all these magnets, but now you can do it on one material. So uploading all of these videos and trying to duplicate these magnets for myself, I influenced a couple friends, Russ Grease of RWG Research and Electro 1662 on YouTube. Now what they did is they had a little better setup than I did, rather than just a car battery. And they were able to actually duplicate CMR's process and imprint some dots onto a material. And you can see that on this videos on this next slide by Electro and Russ Grease also. There's a problem though, because this is still a standard process. And the dots of magnetism and those little maxils are still subject to certain laws. And to give you some context to that law, this is Ernst Abbe. And an Abbe limit has to do with lasers, like when you're point a laser beam at a wall or you're trying to make a CD or a DVD, burning it with a laser. The diameter of the laser can only be so small. You can't go smaller than the wavelength of the light of the laser that you're using itself. So there are tricks to get around that, and there was a article by Gizmodo which shows that you can fit almost a petabyte, that's like 1,000 terabytes of information on one disk. But you can't do that with a normal laser because the laser's dot is only so big. If you want a smaller dot, they had to have a trick where they're using 2 laser beams to focus, and then that focal point will make a smaller dot. Similar concept as what CMR is doing with their magnets. You could only wrap a coil so small. If they want to make a certain size and intensity maxil, then they have to have a certain metal core. They have to wrap that coil and hit it with a certain current. Now, in order to make that, you have to have a certain strength of current go through the wire, but the wire itself better handle the strength of the current. So you can only wrap a coil so small if you want to make that maxil. So you're limited to the amount of maxils that you could fit on a material, and you're limited to the amount of strength that they can have. It's still an advancement, but there's a limit to how many things you can fit on that substrate, which is like Moore's law, which has to do with the amount of transistors that you can fit. And Moore's law says that the amount of transistors doubles every year, every so often, until you're going to have to go smaller and smaller and smaller, at which point you're going into the quantum realm by the year 2020 or so, and you're going to have to figure out a different way of doing things, because you can't go smaller than a certain amount. Just like this process of imprinting maxils, you can't go smaller than a certain amount. But what if there was a way to imprint an actual waveform into a metal? Not dots and polarities. You're not trying to force together magnets, but you're actually magnetizing a frequency into a magnet. And this is a very different concept. And this is one of the most interesting things to me that I've come across in this this journey. Let me get to it here. Now imagine, as an analogy, cymatics with magnetics. or imprinting an electric signature or waveform into a metal. Now, I'm not talking about imprinting maxills, but rather making a material that's finely tuned and you're finessing it, like making a tuning fork, something only one man has explored. Everything magnetic related, I think this is one of the most fantastic concepts, one of my favorite out of this presentation. And this is about magnetic waveforms. And all of the examples of magnets, they're all made using the same high capacitive discharge, like hammering the metal with a current just to saturate it and get a magnet. Nobody pays attention to the frequencies used, the timings, and so many other factors. It's like people have argued as if to say we've discovered everything and there's nothing else to know about magnets and to just read a physics book because there's nothing else going on. No, for some concepts, we don't have the luxury of Google or looking in a library or even asking a peer. When you have a new concept, a new idea, there is nobody to turn to. You have to explore it. You have to investigate it yourself. But you have to have the resources to do so. But when it comes to magnetic waveforms, the only place to turn is through R&D and experimentation. And in San Diego, California, we are doing just that. We're leading the uncharted science of studying these magnetic waveforms, a completely revolutionary approach to magnetization. And this follows the work of John Searle. Now, whenever you're looking into something controversial, you have to look at from different ways. And I put this chart together so that people can get a concept of how important things are to look into or not look into. So there are 4 options and 4 scenarios. Something is true, something is not true. You try something or you don't try. If something is true and you try, you might actually succeed. You can discover something revolutionary and beneficial. You could create jobs and industries. You could become energy independent. You can create solutions, feed people, help the world type thing. It's a limitless future, limitless possibilities. Let's say something is true, but you don't try. You fail at life. If something's true and you don't try, you lose everything and you gain nothing. If something is not true and you try anyway, you still might discover something revolutionary. You might create jobs and industries. You might become energy independent and still create solutions and help people. You can teach people the right way of doing something if you discover that what you're looking into isn't true. But if something is not true and you don't try, you lose nothing and gain nothing. So you can eliminate 2 realities just by trying to do something. Look on that scale and see how much benefit is there of one side or the other if you try versus not try. You could really discover something and open the world up. And another quote, one of my favorites, scientists of today substitute mathematics for experiment and wander through equation after equation until building a structure which has no relation to reality. And when it comes to the concept and the claim of magnetic waves, that's a reality. And we are exploring that new branch of science. This is a picture of Fernando Morris. He's an electrical engineer, worked with IBM for many years, is a satellite communications and troubleshooter. Extraordinary claims require extraordinary evidence. But acquiring extraordinary evidence sometimes requires an extraordinary approach. How can you expect to find something extraordinary if you're using ordinary means? What we have in San Diego is a compilation of extraordinary evidence to support the notion of magnetic waves, which again opens a new branch of science, discovery, and application for energy generation, medical, transportation, and a lot more. Now what you see here on the right is Fernando in front of a bunch of UPS batteries, uninterrupted power supplies. And that's what's required for this type of work is major power. We need about a megawatt of power, which our current building just cannot handle. So this next slide, this is a visualization so you can get an idea of the context between the difference of regular magnets versus magnets imprinted with waveforms. Standard magnets only have one north and one south pole. The point is that there are different ways of making materials which result in different behaviors and beneficial effects. If you use an incoherent process to make a magnet, you'll reap incoherent electricity. Incoherence is heat, resistance, turbulence. The theory is that temperature we feel around us is disorganized electricity. And I liken this magnetic process to like a magnetic prism, in a sense, where the result makes for a coherent flow of electricity, but when used in a specific orientation with other materials. Magnets alone are not a power source. Magnets are not batteries, but they are a means to generate electricity. And if we focus on a different way, there are more beneficial and clean ways to generate electricity, which don't result in radiation and everything that we are used to now. Now, wouldn't it be revolutionary if we didn't need to waste millions of dollars pouring liquid nitrogen on magnets to make them levitate? Everybody loves levitating. Everybody loves the hoverboards, and everybody wants to fly. But what if there is a way to lower the temperature just as a byproduct of drawing a load to generate electricity? When you increase a load, draw more energy, normal systems heat up, they create more resistance, and the energy itself is analogous to like white snow on your television or static on the TV. That's like Brownian motion. And what you see in the upper left pictures is a magnet levitating over a superconductor. That's called flux pinning. Everybody loves these experiments. But in all of these experiments, they have to pour liquid nitrogen or use helium, and that's what they're doing at CERN. And it's very expensive to try to keep something levitating or keep something cold. But what if there was a way to make a magnet which resulted in cold? That would make something coherent, because incoherence is disorganized, incoherence is heat. But coherence, all of that energy is still present, but not turbulent. And this concept is very important for people to understand. And here is a little graphic by NASA. What is ordinary light and what is a laser light? And you can see that ordinary light, sunlight, incandescent light is varying frequencies, disorganized, varying wavelengths, out of phase. But when you have a laser beam, everything is focused and collimated. And you have a flashlight, makes light into a cone, but you have a laser beam, it's really focused beam in a specific color. Laser beam is like a sine wave of light. Now, what if you make a geometric array of physical ridges equal to a given wavelength of light, like a morpho butterfly wing? When you look at the morpho butterfly, it has these little physical ridges, and they equal a specific wavelength. It's not pigmented, it's not a dye, it's just the physical geometric structure of the wing itself, and when you look at it, it looks metallic blue. But what if you can imprint an electric signature into a material which can mimic that type of behavior, so it guides energy in a different way? So pouring liquid nitrogen in an attempt to force cool a system is like watching the static on your TV in slow motion. Reducing the incoherence, reducing the speed of the incoherence present is not the same as generating coherence. So chaos in slow motion does not equal order. We are ultimately after a coherent electric field, coherent electric currents. This revolutionary magnetization process that I'm talking about with magnetic waves is a means to achieve that inevitable goal. Coherence of mind and coherence of the very electricity we use. There are major similarities between light, electricity, and magnetism. They're all related. In this little excerpt called Light as Air, That was taken from an article about Eric Lathwaite, who is the father of the maglev train. And many people don't know that his other work, not just with magnets, he liked to work with photonics and crystals and the geometric array on butterfly wings and on bugs. He was fascinated by that and how it related to magnetism and electricity. Now, this next slide, speaking of the maglev train and more levitation, this is called eddy current repulsion, diamagnetism. Usually a menace in electrical engineering applications, but with magnetic waves, we could use these forces to our advantage for frictionless magnetic bearings. What you see here is a large spinning copper ring underneath this strong neodymium magnet. The motion of the copper alone generates these eddy currents, which repels magnets. So the magnet will hover if you put it over this rotating copper. There's no magnets in the copper, it's just rotating mass of copper. So if you have this magnet over the copper, it will levitate, but it won't spin. If you have that magnet 90 degrees, it'll want to spin, but it won't hover. So wouldn't it be revolutionary to imprint a coherent frequency into a material which generates a wave? What would happen to that material? It would levitate and spin, something that normal magnets do not do. It's one or the other. And that is something very highly sought in superconducting research. If you could make something levitate and spin, that's like a holy grail of magnetic research. Frictionless. Here are some contrasts between uniform and random technologies. So people can pause the screen and take a screenshot of that. On the left, we have these images on an oscilloscope, not of an electric wave, but this is of a magnetic wave, of a rotating ring with a Gauss meter, and you see this magnetic signature on it. In more examples of this, really it's an electric signature which displays and manifests as a magnetic waveform when the material is spun. And what you see here on this green film is an exaggerated version of this true waveform imprinted onto this material. And Fernando Morris discovered this way to duplicate these magnetic waveforms. Now, this is a new branch of science of programming waveforms into magnetic materials. There is no literature. You can't research this. It's something that is unique to our facility. You can't outsource it. It's something that only we seem to be focusing on. You can't purchase these magnets from a Chinese manufacturer. These are a unique blend of materials. This is not something that you buy from China or you can, just get off of your refrigerator. These are uniquely made magnets. And these magnetic waveforms lead to this inevitable reality of a limitless future in energy with these coherent electric fields. I personally spent 8 full months discovering a way to make these new magnets from ingot, from the raw materials. They're very special and they're one-of-a-kind magnets. These magnets, you can machine them. They're machinable. Like you can drill through them. You can shave them down. You don't need any oil or water. You can take any type of drill. It's something you cannot do with any other magnets. Not only that, but you can take the shavings and the leftovers, and you can press them back into another magnet. You can reuse it again. Something else you cannot do with any other material. You can also measure a resistance across the magnet. So normal magnets, if you take a ceramic magnet or an Alnico magnet or something, you put a voltmeter to it, it'll just short out. Beep, it won't show anything. Or you take another type of ceramic magnet, it won't do anything. There'll be nothing. It'll either short out or you get nothing. But with these magnets, you can actually measure a few hundred ohms resistance in them. So it's different. You can also rub them and get a static electric charge in addition to the magnetic field. So, just a very different material. Now, anyone who's interested in more about these magnetic waveforms, please take a look at this video I put together called Magnetic Waves, Coherence, BEC, Geometric Structure, and Casimir Force. It's about a 45-minute video, and it'll give you a lot of context with a lot more hands-on demonstrations of what I'm talking about. Because again, this is a very new topic and a very technical topic, and I can't cover it all in this one talk or even mention all of it. So a lot of what I'm showing you is just to show you that it indeed exists and for you to further investigate the information from the information in the slides. So lurking on these magnetic waveforms, again, got the attention of my friend Russ Grease of RWG Research and Isaiah Ritchie, who goes by Wood, Brass, and Glass on YouTube. And they had some extremely unique ideas on trying to duplicate these magnetic waveforms that are made with an actual electric signature. They're trying to duplicate it so they are cutting pieces of metal, and then they put the cut metal on the put it together, and then when they energize it, the lines will match the cut pieces of metal. So you actually get a waveform when you roll the magnet, and they have examples of that. And I thought that was extremely unique. But still, it's a conventional process using the same 60 hertz or same unregulated, unmodulated currents. And this is what we're after. So if we had proper funding and support, we could hire these types of independent researchers, and that's our goal, is to have a few personnel and about a megawatt worth of energy to use on this project so that we could make these magnets and make them large and prove out more of these claims and show and display their benefit and apply them. We are ready to create jobs. We're ready to offer discovery in unexplored areas of magnetic science. The core technology behind the magnetic waveforms is called the Searle effect, which enables natural ambient sources of energy to be converted into useful electric power. The manufacturer's prototype we are aiming to build requires 1 to 3 megawatts, say 1, and in a UPS, an uninterrupted power supply. That type of power our current building can't provide. It's just way too much. Blow every fuse in the place. While all of the Brunos, as we're talking about earlier, Pablo and Bruno, while all the Brunos of the world work hard following their ordinary processes, which reap an ordinary linear result, we in San Diego, California are working smart on a nonlinear solution, like Paul from the parable of the pipeline. This newly accepted branch of science is based on magnetic fields that produce radial electric currents. Under certain conditions, a unique gravitomagnetic force can also be generated without the need for liquid nitrogen. Electricity can be produced as pulsed DC or AC, hence can be utilized to supply power to existing electrical grids or supply it on a decentralized basis, driving electric motors for cars and ships. And that's the point, is that we do not need gasoline or oil or nuclear, coal, or even solar panels. We could use these magnetic waveforms in a specific setup to harness the energy that is already around us, still abiding by laws of thermodynamics, and just harness energy in a different, smarter way. That we don't have to, use a shovel full of coal will give us this much of energy for this long. No, we don't need to live like that anymore. We have different ways which we can sit back and harness energy the smart way. And this is an example of the magnetic ring in a material that was just 2 weeks ago made and imprinted with this electric signature that we can test on these platforms, which is like a dynamo. Like when you get your smog check, it makes your wheels turn. Same thing here. You make this ring turn, and we test the magnetism in it and the Gauss, and you can see it's gradients. You could see it waves up and down. You could see its variations. Now we are trying a brand new process in San Diego with 3D printing these magnetic materials, something that I've never seen attempted before, and we have successfully tested. What you see here is a 3D printer specifically for metal, and we were able to print a ring out of alnico powder, and I was able to pulverize it and have this machine print out a ring, and it worked. So this has the potential to fully automate the preparation and magnetization processes to offer a one-of-a-kind service that you cannot seek anywhere else in the world. What we have established in San Diego is a scientific foundation to study magnetic waveforms in a testable and professional environment. This has been many years coming. After 6 years of establishing the facility in San Diego and working hard to acquire these pieces of equipment and get as far as we are today, we finally have a working test platform to imprint these magnetic waveforms onto materials and see what they can really do. So that is a major achievement at SMI in San Diego for us, is that we, again, finally have a testable platform. The amp racks are up and ready. And on a small scale, on these small rings, we are able to imprint these magnetic waveforms. So it's a phenomenon that has been validated, and we can show it and repeat it. Now, one of the last things I wanted to show is context regarding these coherent electric fields, and what's the benefit of that? Well, looking back at the structured water, that distillation process that makes that special electric bond retain in that water, in order to do so, you have to have it under a magnetic field and a coherent electric current. And that's what helps to make that state of water. So what happened with this man, Guido Ebner? He was doing electrostatic experiments in his own home, and he found that his house plants would rather grow toward the electrostatic source more so than the sunlight in the window. Everybody knows that plants need sunlight in order to flourish and grow. But for some reason, his ferns were flourishing more, growing towards his electrostatic setup and his static electric field, an SEF as he called it. Now, even stranger, he took the seeds and he bred, let's say, that next plant of that same fern. But when he did, that next fern looked nothing like the one before. Unprecedented change in one generation, like evolution from the same plant. And that was all while it was under the influence of this coherent static field. So he tried it with trout, and he grew some trout under this influence of static electric field. And the first generation looked like they normally do, but the second generation under the constant static electric field looked nothing like the ones before, were healthier, bigger, more vibrant, just different, majorly, noticeably, documentedly different. And rather than actually evolving, it looked more so that the plant and the fish reverted, because I read somewhere that the type of trout hadn't been seen since like 100 or a couple hundred years. Like it was an extinct species of that trout that somehow restored the original potential. And I've heard claims that this Ebner effect can reverse GMO damage in genes and food. So you can make corn back to its original state again if you have these seeds under a static electric negative field. So imagine what we can accomplish within a generation by supporting these branches of science and the concept of coherent electric fields and magnetic waves. Not only power our homes and industries, but also restore the air, water, and quality of life for every being on the planet. not a utopia, just a smarter way of living, while providing future generations with the clean world to inherit that they deserve. And the last thing I wanted to show, since our planet is like a giant magnet and has a magnetic field, and the sun has a magnetic field and indeed interact, for people to seriously look into suspiciousobservers.org and all of these websites, and Ben, who is going to be speaking at the next Electric Universe conference this next week, talking about the relationship between the sun and the earth, and how the sunspots and coronal discharges and everything trigger earthquakes, and how Birkeland currents interact, and how the magnetic fields on a cosmic level interact. So I hope you've enjoyed some of this information. There's a lot more to share, and I have a lot more information throughout the links. Please contact me. Again, my name is Jason Verbelli, and this talk, Our Inevitable and Limitless Future, A Magnetic Field of Dreams, is brought to you by the Global Breakthrough Energy Movement. Thank you.